one thing I should mention is that we are recording this. So as of just right now, I just pressed the button for recording. So just as an FYI, we do record these so that people can go back and try to listen to them. I've posted the unedited versions of our previous chapters up in Slack. Chapters 2 through 4 are up there. We did not do a recording for chapter 1. So the unedited versions are up in Slack if you do ever want to go back and look at those. Okay, so chapter 5, Dictionaries and Structuring Data. Let's go ahead and jump in. Okay, so my first question, just for open question, is what is a dictionary? Compared to last week we were talking about lists, and last week we were talking about tuples, and the week before that we were talking about strings. So I guess how does a dictionary differ from all of those other things that we've learned?
It contains a key value pair.
Okay, so what does that mean? Like, what does that really matter, I guess?
So think of it as, let's say, we're associating one primary key, something that is total. We want to have a sequence or that's immutable, and it describes something. Let's say we're talking about one person, and the values for that person could be a list. It could be one thing. It could be my name. It could be person number 1 in the list. But in that list, I'm Kevin. That's I think the best way for me to describe it.
Yeah, I think that's an excellent description. That keys are more human accessible or more accessible labels as a way of looking up, as opposed to an index for an array or a list or a tuple or something like that. So if you know what the key is, then you can find the values. So it makes sense that it's named a dictionary, in my mind at least, right? Because what do you do in a dictionary? You look things up by a key, the key being the letter of the alphabet that word falls under.
Oh, good. I like that. I like the tie, bringing it back to why this is called a dictionary. Yeah. So what I have highlighted is sort of like an example of what we're talking about here. It's this dictionary. If you're looking at this line that I have highlighted, how does this differ the way it has been defined compared to lists and tuples? What's the very first glaring thing you see different?
You have brackets instead of, what's the other one?
Yeah, yet another type of flavor of bracket.
Yeah.
Yes.
The curly braces.
Yeah.
Well, braces, yeah. I would say brackets.
So we're using curly braces here. Let's see, I believe, if my memory serves me correctly, we were using for lists, we were using square brackets, and then for tuples, we were using parentheses.
Yes.
So now we are progressing our way through the rest of the symbols, and we are working in curly braces. That's the first big thing I see. Other differences you see between this and the way lists and tuples are defined?
Your keys, the way you use your keys, you don't have to have just numbers, you can have words.
Right. So like before we were saying, well, actually, in lists and tuples, we never even defined the key. It was implied, right, based on position. And please correct me if I'm wrong, but when we were doing lists and tuples, we didn't even say like position 0, position 1, 2, 3, or the index rather. We are now actually saying for this is what I want here. So for this key, I want this value.
Yeah, so one thing that is different about Python from, say, Java or some other languages is the fact that we call this data structure a dictionary. Mm-hmm. In a lot of other languages and in computer science texts, you might hear the phrase hash map, which is what this data structure is classically called. because of what you just pointed out. So for arrays and for lists, there's positional data, right? And so the implication is that there is a key that's an index, right? That points to the position of the thing in the data structure. But for hash maps, you have a key that maps to a value, which is the map part of the hash map. And then hashing, we don't have to go into right now, but hashing is a way for the computer to identify where something is in memory really quickly. But yeah, a dictionary is essentially a hash map. So you have the key, and the key basically points to a place in memory where you will find the value, the corresponding value.
Oh, cool. Thank you for the correspondence, like making this connection with other languages. Because I have just added that to our list. Remember how like last week, I think we were saying make little notes along the way. So I made like a PDF of notes that we can have, and I'm going to try to publish these so that as we make little comments, we can sort of just see them. This is similar to this, conversation that we have as we go along. So
that's amazing. Thank you for doing that, Jamila.
In case you see that pop up, that's what's happening there. Okay, Vivi. Let's see. Okay, so we have our keys and our values. Something I'm noticing about these keys is that they look like strings and that they have the quotation on the outside of them as well. Is that like across the board all the time whenever you use dictionaries, the keys are always going to be a string or defined like that?
No, the only requirement for a key in a dictionary is that it be hashable, which is this computer science concept of, I don't know how to explain hashing. Can anyone else explain hashing? It's a way of uniquely identifying something. You run it through an algorithm, and if you can get a unique hash out of it, then you can use it as a dictionary key. And because that hash is unique, your computer can find it very, very fast. So that's kind of the...
So as long as it's a unique value of some sort. So I could have put like 1, 2, 3 there instead of size, color, and disposition.
It has to be both unique and hashable. So the overlap between unique and hashable isn't 100% because a list is unique, but a list is not hashable. One of the requirements of hashability is that it not be changeable or mutable. So you cannot use a list as a dictionary key. You can use a tuple, provided that tuple doesn't have a list in it. So you can use tuples. You can use strings. You can use integers. Integers aren't mutable. You can't use other dictionaries as keys, but you can use other dictionaries as values. So that's the one requirement. Here they use strings because it's very straightforward and it maps to the concept of a dictionary. But you can use numbers, yes, definitely.
Okay. Cool. Okay, so what I'm seeing here, this is an example of us actually referencing what the value is, similar to the way we did it with lists and tuples. So, but instead of seeing a 0 or a 1 here, we're actually using that key being declared to figure out what that value is and see it returned.
I also wanted to point out...
oh, there's the answer to my question. I don't know why. I didn't read that. I'm sorry. Go on.
I was going to say one of the things that's also unique is the colon.
Yes.
Very good. Yes. Thank you for reminding us. That's really important.
Yeah, these quotes are going to trip me up every time. Like putting quotes on the key and on the value, like remembering that. I think when I wrote it a couple of times, I kept forgetting at least one of these just because seeing so many quotes in a row is different. Okay, well, I think this is pretty much covers this section. Does anyone have any questions just about what a dictionary in general is before we move into this next section? Okay, so comparing dictionaries to lists.
Oh, that's very interesting. If you highlight the dictionaries are no order.
Yeah, so that is very interesting.
That's very interesting that we have to mention. The new Python version is not like that, right?
Yeah, no, that's a good point, Liliana. And I, as somebody who learned Python 2 and then Python 3, and now more recently trying to get up to speed on the features in Python 3.7, this has bit me in the butt. I cannot tell you how many times, right? So ask for something out of a dictionary, which is inherently unordered, and or iterate through it more than once, and you'll get something different.
Okay, wait, hold on. Let me first level set what I'm seeing here, just to make sure it's clear.
Sure.
So here we have a dictionary that has name, species, and age as the keys. And then we have ham that has, once again, name, species, and age just in a separate order. Now, they have different values, but they still have the same number and the exact same keys in them. So when they're evaluating these two dictionaries of eggs and ham, are these equal to each other, that it's coming back as true. So according to this text that we're reading right here, these are equivalent dictionaries.
They are, but notice it's both the keys and the values that match. So name is the same, species is the same, and age is the same.
Oh, I missed that. I don't know how I missed that. Oh.
Well, it's really hard to read when they're not in order.
Yes. So now, but
really hard to read.
But now, if you do this in Python 3, it will tell you it's false.
Okay. So if I do this.
Yeah, and that's a great thing to point out, Liliana. Now in Python 3.7,
that was the first thing I didn't want to forget. Yes. It will tell you now x equals ham.
Oh, it's true.
Oh.
Because the values are the same. The values are the same. The ordering is not, but the values are the same.
Okay.
Yeah.
Good.
So it's comparing the values?
The values.
The values of the keys and the values of the values. And not the ordering.
Yes. So exactly.
So how does what, so you were saying, you made a comment that on Slack, you said that, or there was news that
The
list now are ordered. Before they were not ordered.
Yes, exactly. Yeah. What does that mean, ordered, in this case?
So what that means is that Python, the Python interpreter, is internally keeping, it means it's a larger data structure, because Python's internal interpreter is keeping a list that has indexes of when you add something to the dictionary. So if you add something onto the end of the dictionary, Python internally knows that you added that onto the end of that kind of shadow list that it's keeping, so that it basically remembers the order in which you added things to the dictionary. And that is useful if you want to use the dictionary as, as this kind of general purpose place to stash things, right? Knowing that you can rely on things staying in the same order kind of gives you some advantages in certain scenarios. The disadvantage is it takes up more space, because Python internally is having to keep track of the order things were added in. But they decided gradually over time, and what's really interesting is if you go to the Python Software Foundation and you look at PEPs, which are Python Enhancement Proposals, you will see this debate playing out over, and you can literally see the core developers of Python debating this over the last few versions of Python about whether or not this was useful enough to make it part of the language. And they just decided between version 3.6 and 3.7 that yes, it was something that they wanted to guarantee. So you can now if you don't do anything to like sort it or anything else, the dictionary is going to stay in the same order that you added things to it. Whereas in earlier versions, oh, I'm sorry, go ahead.
Nope, go ahead, finish.
So in earlier versions of Python, I mean, there was always big warnings. Do not rely on things coming back in the same order from a dictionary. But now, as of 3.7, you can. They guarantee that if you keep things in the same order that you added them, Python will guarantee that they stay in that order.
So just from an oversimplification of that, does that mean, like here I printed eggs and ham back again, it came back in the exact order that I wrote it in because it's keeping track of the order that I wrote it in? Is
exactly
essentially what you're saying. Okay.
Right. And if you fired up Python 2.7.14, which we are all thankful will die in January of next year, except for the people who really need to use it, you wouldn't necessarily get that behavior 100% of the time because it wasn't guaranteed that it would stay in the same order. Yeah.
Okay. Cool. Well, that's good to know.
So this is kind of like a learning lesson. I think it's important sometimes to go and check the versions that we're using now and check if things that we're learning are changing.
Yeah.
Yeah.
Well, and so even though dictionaries are now ordered, you still can't slice them like lists. They don't support slicing.
Yeah.
Okay.
So to that end, getting into this next little piece, it looks like this is a common error that you might see if you're trying to call for something that is not a key in the dictionary. So be on the lookout for that and not make that mistake. And continuing on, do we have any questions so far? Just taking a quick pulse. Yeah.
I have one question, actually.
Yeah, go for it.
It kind of struck me there. Is it possible to actually change the key on a dictionary?
No, you can add a key with the same value and then remove the other one. But keys are not, by definition, you cannot have a key that's mutable, changeable, because mutability cancels out hashability.
Ah, got it. Yeah, I was actually I had to think about it for a second because it kind of sounds, if the earlier question of what's the difference between creating a key value with a tuple versus a dictionary, in both cases, the key cannot be changed because for the dictionaries, because it's the hashability context, whereas the tuple it's a tuple. We can't change anything in a tuple.
Well, yes, although there is a bizarre corner of Python that is absolutely useless knowledge. I'm fully aware of this, but my brain is a magpie. There is this weird corner. You can put a list inside of a tuple, which completely invalidates tuple's mutability restriction and also invalidates using that tuple for a key in a dictionary. So if you create a tuple that has a list in it, the list data structure is mutable. Somehow they allow that. And then if you try to use that tuple in a dictionary, it'll give you an error back that says you can't do that because it's not hashable.
That's interesting.
Yeah. Useless, but interesting. All right.
Do we have any other questions before we move on? Okay, moving on to this fun section. This was the first example of us actually using dictionaries in the code pretty heavily. Anyone who already read the book, or at least this portion of the chapter, want to describe what's going on in this code? Or You can try to walk through it now.
Actually, one of the things we could do, Jamila, if you want, is we could walk through that in Python Tutor. I don't know if that's worth it or
No,
not.
you are a genius. Let us do that.
Can you hear me?
Ooh, hey Lisa, how are you? Wait, I thought I heard Lisa. Did I not?
I thought I heard Lisa too. Lisa, speak up.
Oh, she's gone.
She's gone. Maybe she
Oh, wait.
got this connection. Yeah.
Oh, there's still Lisa Adams on the list.
Oh yeah.
Can you hear me now?
Yeah.
Yes.
Yeah, I'm having technical difficulties. It just kicked me out for some reason.
Oh, that's
I,
lame.
I had an issue with this code. My question is, once it gets to the if name, it compares it to an empty string. Why does that break drop down to the else statement instead of just ending the program? If you visualize the execution, you'll see what I'm talking about.
Yeah, you have to, the line 9 needs to be unindented a little bit.
Yeah,
So
I
that's
was.
outside the
I
while
gotta
loop. Yeah.
fix some of that. But shouldn't this too?
Yeah.
It should
Yeah.
be like that.
Yeah. Lisa, to answer your question, why does it drop down? If you look at the while loop on starting on line 3, that is a loop that's going to go to infinity, right? And so because there isn't anything to tell that loop to stop, the only way that you're going to get it to do anything is to break, right?
Right?
So, oh, else print. I do not. Oh, you know what? This may be a printing error.
Okay.
Let me look at this really quick. Break, name and birthdays, else. Yeah, this looks like it might be, that is a really good question, because if I read it the way this is printed online, breaking is going to take you to else, but breaking should take you completely out of the program, shouldn't it?
Right.
Yeah, no, that's an excellent question. Yeah, I think that's an indentation problem. Jamila, what do you think?
I'm sorry, I'm pulling up the one that I know worked. Let me see. That looks the same though.
Maybe it's the blank to quit message that is a little bit ambiguous, because I can see what the intention is, right? The intention is if you don't have somebody in the dictionary, you want to add them to the dictionary, but they're saying blank to quit, which implies quitting out of the entire program. And if you were quitting out of the entire program, right, wouldn't you want, oh, I see. It's
But no, that's what you want. You want to,
loop. Yeah.
you're trying to break out of that while loop. That's the point.
Yeah. Yeah, everything is supposed to be lined up under the while loop. Got it. Okay.
Yes.
All right.
Which is, that's what I have, right?
Yeah, it is what you have.
Okay.
But Lisa, that was a really good question, because it could go either way, right? You could do something where you break out of everything altogether, or you could do something where if you don't have a name, it'll prompt you to add a name. Yeah, both would work. It's just.
But the way this is, if you don't have a name, it will drop down to the else and say, I don't have a birthday information for blank.
No, it'll go down here to this if.
No, it'll drop altogether. If everything is
Wait.
lined up under the while, remember, indentation. So this whole thing is happening, everything, all the ifs and the else are happening inside the while loop, right? So if you break, well, I mean, let's actually walk through it. Let's walk through it and see what happens.
Actually, if you have a break statement in any loop, it's supposed to break the loop and not.
Right.
Why does it think I have an indentation error?
I think
Because
first
9,
ones.
yeah, 9 needs to be out 1. 9 needs to be lined up. Line 9 needs to be lined up with line 6, as does line 11. There we go. Okay, try it one more time.
Well, then maybe tab up 6, since those two are already aligned.
Oh,
Yeah.
okay.
Yeah.
Sorry, like my eye is slightly off.
I know my
And
eyes are.
4 and 5 maybe,
4 and 5
just to
too.
solidify it, yeah.
How do we feel? Yeah?
Yeah. Feeling
Okay.
optimistic. Yay. Okay.
Wait, it's still, I know that. Go away. Okay. So we got our birthdays. Do. So we are building a dictionary, it looks like. And so our keys are the people's names and their birthdays are their values. And now we are entering our while loop. And it's asking us to put in some information. So let's do one that's normal. We're looking up Alice. Okay, so now it's assessing whether or not that name that we put in there is empty or not. And it is not, so it's going to look for Alice inside of birthdays. And so for birthdays where the key is Alice, it's going to go find that birthday, print that out, and then print the rest of this statement. Is the birthday of, and then the value of Alice. So we have April 1st is the birthday of Alice. Okay, and then moving on. Whoa, where did it go?
Let's go back to the top.
Let me make this bigger so you can see everything. Wait, does this go this way? No,
Yeah.
That's awesome. Okay. Okay, so yeah, since it processed this if, didn't even go into this else, went back up here for true, and now it's going to ask me for some new input. So Lisa, we're going to throw your name in here. If the name is blank, it would break, but we have a name, so we're going to go find Lisa's name somewhere in this list. But it can't find it, so it's going to print. I don't have birthday information for Lisa. What's her birthday? So we're going to move ourselves forward.
December 24th.
I don't know why. Okay, there we go. Well, that's a fun birthday.
Yeah.
So we submit that. So that information came into the birthday there. It got assigned. So now birthdays for Lisa is that birthday, and Lisa is now in our list. I mean, dictionary. Dictionary. Okay, moving ourselves forward.
And now you're going to enter the blank. The blank.
Yeah, let's do the
And just
blank.
hit submit.
Okay, so it enters if this name is blank, it is going to break.
Yeah, keep going.
And it's out.
And it
Oh.
stopped. It dropped completely out of the loop. So the second if and the else, notice they're indented. So they're all inside the while loop.
I wonder if there's a difference between just not typing anything or entering just a space.
Well, space is a character, isn't it? So it's going to be, it would actually be not empty string, but
Space. Well, let's give it a try.
okay.
Thinking like a QA person. Why not break it, right? Oops. Okay, let's see if it catches it.
Nope.
Uh-oh.
I think that was it.
I don't have information for a blank person. What is their birthday?
See, I must have entered that space instead of just hitting the submit.
That is a very easy thing, which is why we need more QA engineers in our lives. There should be an OR check in there.
This is why I have a job.
And why you will continue to have a job for a very long time should you choose to choose to remain. How would we fix that?
What are you guys talking about? Because I got disconnected and I was trying and my internet went down.
Right.
So this is saying if it's an empty string, it's going to stop the rest of this program. But if it's a space, which is not the same as an empty string, it will continue on with the program thinking a space is a valid name. And that's probably not what we want. Even if it's a space, we want to say, nah, we're not taking that. So our question, Bethany just posed the question of how do we add a little bit of error handling here? If someone throws in a space, how do we handle that? How do we edit this code appropriately?
Name.split and put a space for that.
You can use the strip function.
I like that.
Just add an or, no?
Well, then you'd have multiple possibilities for things to be handled. But if you really don't want initial spaces or trailing spaces or spaces in itself, so you can just strip it. So you only have character beginnings and endings.
That's an excellent way to do it, and I hadn't thought about that. Another way is to use an in check and do a list of values. Or you could also, which would be way too heavy-handed, is you could use some sort of regex that stripped out what are called white space characters, like the tab character and the space character. But I like strip, because if you use strip without anything in it, it will omit all white space characters by default. So that's a great one. I like that.
If we did this twice, like let's say if we did it first, learning what we learned between chapters 1 and 4, would or be an appropriate way to do it?
Or
in.
Yeah.
So I'd like to do it once based off of things that we learned between chapters 1 through 4, just for the beginners in the room. And then let's try it again with learning something new, like with the strip feature.
Let me go check and see if in is part of, well, let's do an or. It doesn't hurt us to do an or. Let's do an or. That makes it really explicit.
So are we doing, I can't remember if is it this, or are we doing or in Python?
I think it's or, like that.
Okay. If this or that. So if
I think you have to list name equals twice. I don't think it'll do that. You have to do name equals, yeah. Let's see if that works.
So if you can't tell, I have no space in between these, but in this one I actually do have a space. So we're saying if you encounter nothing, or if you encounter at least a space, we're going to break. So, did I break something? I haven't break anything. Okay, let's go forth and try that. Putting in a space, submitting, breaking, done. So it looks like we can do it with just the space.
Hey.
So that's just the simple way that we learned between chapters 1 through 4. If you remember the or keyword, that's how you would use that. Now let's learn something new.
So does anyone here though, when they look at this, know the weakness of this approach? This is a great approach if you know it's going to be one thing or another thing, but what happens here? Because humans are very mischievous. So we're checking for nothing and we're checking for space, but
We're not checking for all the other possibilities of space space and space space space.
And tab space and ad nauseum. Yeah.
So that's why we're going to this other way of trying to capture as many of those weird combinations as possible.
Yeah.
So this is great if we want to declare everything possible, but since we don't have the time for that, we're going to do something else.
Yes.
So can you walk me through this one? If name, or no, you wanted to strip it, or?
Either strip or we can do, let's see.
Is this a method?
This is a method. This is a string.split. So what you want is name.split, right? Because name is the string, right? Is the input. But let me just, I'm checking the docs right now for split. We may want strip as opposed to split. So let's, because they behave differently.
Okay.
No, we want strip. Let me find strip.
Yeah, I get those two confused.
Can
Too. Strip leaves the characters in the middle alone. Split might give us a list of letters back, which is not what we want.
Okay, well, while you look that up, I'm going to see what happens. If you split, okay. If name split, it breaks. Huh.
Yeah, we don't want, but what you would want is if name.split equals empty.
Yep,
Is,
I realized that halfway through.
Yeah.
Nothing. Let's try that again. There we go. Okay, so empty, it still keeps going.
Yeah. Sorry,
Name is now something interesting. Is that what it was before?
what?
I was just looking over here. The symbols just look funny in my head. Also, I need to turn this off. Sorry. Okay, so we want to try strip instead?
Yeah, let me paste this in for you.
Oh, in Slack?
I pasted it in the Zoom group chat, but I'll paste it in Slack as well.
Oh, sorry. Gotcha.
No worries.
Okay, so that's what we're using. We're typing in.
There's a right strip and a left strip. My assumption is that, you know, if what we're trying to do is remove white space, left versus right is not a big deal.
So we just take the string and then we just apply our strip on the end.
Mm-hmm.
Gotcha.
I think so. Our strip with no specifier, because then it'll get rid of.
Okay, so going forward, trying that.
Although we could technically, now that I'm looking closer at the split documentation, which I will also paste in there, you can get away with splitting an empty string and it will just return, but split returns a list. We really don't want that. Never mind. Split returns a list.
Wait, hold on. Why did I not break?
Because you need to have a test in there, right? If name.rstrip equals, yeah, you need to test for a value there. Yeah. Because it's always going to be true if you're using it. Yeah. I do that a lot too.
Doing this and talking at the same time is not really great on my, it's really...
I think there's only ever one human I've ever seen who can type and speak at the same time, and that's David Beasley, and I'm not quite convinced that he's human.
Okay, there we go. Of course, evaluate something. That'd be nice. So R strip. Okay, cool.
So go back and try as input, just visualize again, but try as input like a tab character and a space, and see if...
Make sure it covers our bases.
Sorry, humor an old QA person.
Okay, so I'm going to throw in a space.
Habits.
I threw in a space.
And it's
still going.
It's not. Oh, no. Your test, you don't want name equals name.rstrip. You want if name.rstrip equals, and then nothing, right? You need a test to show that once you've stripped something, right, we're testing to see that there's nothing left over after the strip happens. Yeah. Let's try this one time more. Okay, try space.
Breaks.
Okay, try space. Like,
is there a way I can...
Ooh.
Uh-oh. No!
Oh, man! Oh, that's lame! Python tutor, you failed us.
Okay, it's fine. We'll do this again.
We have the technology. We can rebuild it.
It'll be fine.
Oh, God, I'm so full of it today. Okay.
So this is where we said if name.rstrip and we pull that in and we pull that in and the rest of you are good. Okay. Anyone see anything?
Yeah, the break line on line 7 and on line 10 for the print. It's not a line. Looks good so far, yeah.
Thank you. Okay. Again. Space. Break.
Voila. Okay. Now edit this code. And then visualize again, yeah. I guess you could back up, I suppose.
Oops, sorry, wasn't thinking. We're gonna tab. Wait.
Yeah, do a tab space or a tab, just, yeah.
I don't know if tab's doing that.
Yeah.
Oh, because of the form, yeah.
Yeah.
Just several spaces. And we don't have to beat a dead horse.
Yep, that one terminates too. So that is acceptable. Instead of just saying if name equals empty string, we just added the .rstrip. And then we're good to go.
Yay!
Okay, saving this code. Oh, that's right. We were going through a book. So that's that section of basically going through the birthdays and finding people in the dictionary and returning out their birthdays. Does anyone have any questions about that little piece of code before we jump into methods?
Well, there's another typo in the book.
Ooh,
Down where it says spam equals color red, age 42.
oh, here. Okay.
It's down under the list spam dot keys. List spam dot keys.
Here.
Yeah, a little lower than that. It's right at the bottom, right there. Their output is reversed. First, it should have color. The color should be on top.
Okay, so let's get to that. Let me just do a
Oh.
quick primer for this section. So
Okay.
keys, values, and items. No, thank you, Lisa. Definitely going to hit that. Just so you know what we're doing though with this is we're returning information by applying these methods of keys, values, and items. So if you want to know the keys that are inside of a dictionary or the values that are inside of a dictionary, you can just use these methods and return that information. So in this case, there's a dictionary for spam that has the color of red, key, value, and then the key age for 42. So what it's doing is it's iterating, or it's iterating through this dictionary, and it's using this method called values and returning all of the values by printing it. So it's printing off red and then 42. So you can either use the values to return that, or the keys method to return the labels, essentially, or the items, which is basically the key with the value. And so it looks like that. So if we're coming down, I'm sorry.
I was just going to say what's interesting is I just did this in my Python 3.7 shell. If you do spam.keys, it gives you back this dict keys object with a list inside it, which is kind of interesting to see print out on the command line.
Okay, so
if you just, you can just do here, you can do eggs.keys, yeah. Isn't that cool? So it's literally returning a list to you.
Yeah.
Ah. And someone just asked, will it always return in order? The answer to that,
now that it's ordered? Oh, sorry.
Go ahead.
No, I have no idea what I'm saying. I was just wondering if it should, just because it's ordered now, right? Or is that?
Yeah, well, that's an excellent question. It should because it's ordered. So I'm going to go look that up in the docs. You continue, and I'll look it up in the docs. And
okay. So I'm just going to print hams as well. So ham.keys does species age name, and ham here was species age name. So it looks like maybe it's at least ordering it in the order that we input eggs and ham. But Bethany's going to confirm that for us, it sounds like. Okay.
I have a question, actually.
Yeah.
So when it's iterating the, say, for I in spam.items, and it's using that items method, does it return, it looks like it's returning a tuple? Is that correct?
Mm-hmm. It returns the list of tuples.
Okay.
So if you go, like, Jamila, if you go back and do ham.items, print I. Yeah, but if you just type ham dot.
Oh, I'm sorry.
No, that's okay. You'll notice what it's doing is it's a list, and inside the list are tuples, and the tuples are pairs. There's the key at 0 and the value at 1.
Ah, okay, that's interesting.
So tuple 1, tuple, no wait, tuple 0, 1. Got it.
So you can do things like ham dot items bracket. I think. Now this will probably make me a liar. No. You need the parentheses for the function call, and then after the close parentheses, do a bracket and do 0, close bracket, and then another 0, another open, yeah, okay. And see if, no. Dict item object is not subscriptable. Okay, so you cannot, even though technically this is a list of tuples, you cannot subscript into the dict items object. It's telling you can't index into that, but you can iterate through it and print them out.
Is it possible just do, instead of 0, 0, just 1, 0?
Try 1, 0, but I think that what it's telling you is you can't get at the list in the object.
Is that what I heard?
Just one number instead of 2 numbers. Yeah.
Oh,
Yep.
Oh, sorry. Gotcha.
Yeah.
Oh,
No,
yeah.
you can't do that. But one thing that you can try is try ham.items and then put it inside of a list constructor. So convert it to a list. That may not work either. You need the function call.
Yeah. Yeah.
Yes. So you can do that. And if you did that, then you can index into that because now that's a list data type instead of an items object. But
and that's what they were having us do right about there. It's we were applying that list. There.
Yeah.
Interesting. Okay, why am I seeing tuples and I'm seeing a list over here? Oh, because we're doing items.
Right,
Oh,
items
so
is both.
List
There's
of
values, yeah.
Gotcha. There we go. Because it's trying to maintain that relationship, so it's showing it as a list of tuples. Okay. Huh, that's cool.
So that becomes useful if you have to go through the whole dictionary and, you know, do something with every single thing. You know, you can, you know, iterate through it using that. So you don't have to do, it used to be that you had to do something like call a list of keys and then go through the keys calling the corresponding values, but with items you can get both in one shot. So
I should have been doing this the whole time. This is the solution that I've been looking for. It's like I've been doing what you just mentioned before. I was pulling, basically, long story short is I've been hard coding a lot of my things, but I needed to, so I don't want to share, like, for example, my username and password with everybody if I shared my code. So I use the JSON file from an external JSON file that I can just put in there. I would pull it in. But every time I would try to change the contents of that file into a dictionary, I would then have to parse it again or convert it again into a tuple or a list. And I think this does it much more cleaner than actually going for a full, the way you mentioned earlier, just have to pull the keys out and just try to call each of the values that's inside it.
Yeah. Yeah. No, it took me a really long time to discover items as well as enumerate, which is kind of a similar method for lists that'll give you the index and the item in the same, right, in one shot. And boy, was I happy when I finally discovered those. Big happy camper.
Okay, so let's look at this typo Lisa was mentioning. So what's it trying to do? Oh, it's trying to go through assigning multiple values at the same time. So you have colors red, age is 42. So it's taking in those items and applying the the key to the K and the value to the V, and then printing those off, and then going back through that list and doing that for age and 42 as well. So, Lisa?
I was thinking the color value, the color in red should be on top, and age and 42 should be on the bottom.
And it may be true in Python 3.7, but But that isn't necessarily true in earlier versions because dictionaries are unordered before Python 3.7, which means that every time you go through, it could be a different order. Remember, it's going through these in order, but the order is not guaranteed before Python 3.7. And there's a similar question in chat about keys always returning in order. I'm still tracking that down. I want to get a definitive answer from the docs, and then for some reason my Google Foo's not working. But yeah, so he did that on purpose. I think that's not a typo. That's true. If you did that in Python 2.7, you couldn't guarantee that color red was always going to be first.
Because yeah, he wrote this book before 3.7.
Before 3.7, yeah.
And so that's why he has this line here, wherever it was,
about not being ordered.
Are not ordered. And so at least at the time of this, when he was writing this, they were not ordered. So
yeah.
Okay.
Python 3.7's only been out for 2 years, I think, or a year and a half or something like that.
I think they're already beta testing 3.8.
They are beta testing 3.8, which has a walrus operator, and that's a whole nother story. Yeah.
any other questions before we move to the next section? Okay, checking whether a key or a value exists in a dictionary. We're using that in keyword again, or not in. So that is available to us, just like it was available to us in what? Where did we use it before? Previous data types.
I didn't attend the earlier lectures, but I'm fairly sure you could use that in lists.
Yep. Lists, and I feel like we did it in something else too. Well, I think if we did it in lists, then we probably also did it in tuples.
And you can use it in strings as well.
That,
okay. Yeah.
I was wondering about that because I was like, it seems like we did it as early as strings, but I couldn't quite remember the example. Okay. Okay, the get method. I guess my question for the group would be, why would you use this feature using the get method?
Well, so if you read that first paragraph, I'm sorry, I just stepped on somebody. Speak, whoever it was who's going to.
I don't know if I heard anyone.
Okay. I was going to say that he explains right here. So part of the downside of using a dictionary is if I'm going through and I'm trying to add things to the dictionary, or trying to retrieve things out of the dictionary, if there's not a key already there, it's going to toss an error. So get is a way of checking before you actually get an error tossed.
So for example, in this picnic items, we have our apples and we have our cups. So if I want to see how many cups, 2, we have, I can say, go get whatever the value for cups is. And so it says, I'm bringing 2 cups.
Right, but notice that the second parameter of get is a default value. So instead of getting a nasty error back that you have to check for, it'll just be like, oh, I didn't find cups, so that means 0.
Exactly.
That's the difference between looking at it via the key index and using get, is that you can be a little more graceful when it fails to find something.
So that's why we're seeing for eggs, which is not in our list here, it throws out a 0 and it doesn't throw out this fun error. Because eggs is not there. So basically you want to use get instead of just using just the key when you're not necessarily sure that key is in the list. That's what I'm understanding. Okay, so then that's our get. Does anyone have any questions about get before we move into set default? So set default, to me, it seemed sort of similar, except it's sort of like editing the dictionary rather than providing you something like printing it to the screen. So set default is if color, for example, is not in here, it's going to add color and it's going to set it to the value of black. So if you use this dictionary value, or use this dictionary, apply the method set default, add the key and what it should be, you now have a new dictionary. Why is it not highlighting? That has that item added to it. But it will only do it the very first time that that key is not available. So for example, here you notice they try it again, adding white, but it doesn't actually change it because color is already a key inside of the dictionary. So set default is really only used when the key is not already in the dictionary. Is there like a practical, like in the real world where people actually use Python from a day-to-day perspective, like when do you find yourself using this?
The set default method?
Yep.
So I tend not to use the set default method only because I tend to use a thing called the default dictionary, which is in an add-on module. But set default is nice if you're trying to go through a bunch of stuff and populate a dictionary quickly. So it's for this scenario where if it's in the dictionary, add one to it. If it's not in the dictionary, add it to the dictionary. But if you think through that, that becomes tough to do unless you have something like set default. Does that make sense?
Yeah.
I mean, you can do it, but the code is fugly. So set default gives you a get. It gives you a graceful kind of way out of that. So.
Okay. Well, then, this is the big, well, this one and the next one is the big pieces of code that we have before we stop for today. Pretty printing was the very last section that we were going to cover. So this is the next little piece of code that he had us write. Basically what it was trying to do was count the number of characters, or count how often a character appears in the sentence. So for example, how many times the I shows up in this entire sentence. You had to be able to keep track of that and print it back to the screen. And so this is the code that we had to use in order to do that. So I guess we can go to Python Tutor and watch that in action.
It's pretty cool. I find it pretty entertaining myself.
Oh, look at that. Maintain my indentations and everything. Now this one, I do have to admit, I had to like read this probably 3 or 4 times to quite understand what was happening here.
Do you notice how he put brackets on count bracket character? Not the curly brackets, the square brackets, sorry, for the counter where he's, yeah, there. Why is that square brackets and not parentheses?
Parentheses or curly braces? Which one?
Or curly braces. Why did he use square brackets?
So I'm going to take a stab at this, and Bethany, I'm sure, will correct me, or Kevin will. Whenever we're using the square brackets, if I remember correctly, it's when we're trying to reference a very specific thing. So in this case, we're trying to say, for this very specific character in this dictionary, I want you to add the number 1 to it. So if you think back to when we were doing lists, right? When we were trying to figure out where in the list we wanted to go, we use square brackets to say, at this index. That's the same thing that we're doing here. It's not that we're declaring a dictionary, which is what you do when you do curly braces. What we're doing is saying, in the dictionary at this location. That's why we're using the square brackets.
Yep, that's right.
Okay, thanks.
Okay, so it looks like here we have a message, like a string, this huge long string. And actually, does anyone else want to just walk us through it line by line, what's happening? I'll press the button, but if you want to sort of describe what you see happening, you can. Anybody want to?
Come on, don't be shy.
Well, I'll try.
Go for it.
Okay. Message is a string.
Okay.
Account equals, that's our empty dictionary.
Cool.
4 character in message, that's our for loop. And somehow Python just knows to start at the first character.
So, and I think that's because message is a string. And if we remember from our previous conversations, strings are iterable. So we're going to work our way from the beginning to the end of this string and go through it one by one character at a time.
Is it unique in Python for it to just know in these loops start at the beginning?
I don't think it's unique in Python, but it is definitely a core feature of Python because they wanted it easy to use. Yeah, so Python does that kind of automatically. It assumes that you're going to start at the lowest index number unless you tell it otherwise.
Is this what you call the Python magic?
Yes, it's part of the Zen of Python. Yes, it's or I've also heard it referred to as the 80% solution, right? So the makers of Python wanted to automate what 80% of the people would likely need and have that be the default. In the 20% scenarios, you can get around it, right? You can specify a different start to your iteration, but for 80% or even more of the scenarios, you'd want to start at 0. Like that's what a lot of people would do. So that's what they made it do. In other languages, you can see in C++ and Java and JavaScript, they make you specify all of that in parentheses, which was one of the hard things for me to get used to. But in Python, they said, look, the majority of the time, you're just going to start at 0. So just let that be unless otherwise. So.
Right. So this is a loop for the first character in the message string. Count, that's our dictionary. Set default. For that first character, it will be an I. The 0 is, if it's not there, you're supposed to set it to a 0. Wait a minute.
And it does.
Okay, if it's not there, set to 0. Then the next line is our dictionary count character. That should be I.
Right.
1. No, it's 0 equals 0 plus 1. So it's now a 1.
So, yep, there it is. So it's saying in the dictionary where the key is I, add 1. And remember when we started this, it was 0.
Yes.
So it added 1 to that, and now it got assigned. And we go back to the top. So the next letter will be
T. The next character is T. Give it a 0, and then 0 plus 0 is and 1. Add 1 to it for T. Then it goes back to the loop. There's a space. It counted the space. The W. Yeah.
and
It'll just keep looping through.
right. And so I'm just
And-
trying to get to this next space because what we should see happen on this space right here,
Should go to 2.
right? Woohoo! And then it's just going to go all the way to the end. So when it gets to that very, very last guy,
It's supposed to just drop down to print the count. Print count.
And it's going to do that when it hits that very last character of message. So once it hits the last character in message, breaks out of the 4, and then it just prints count. And what is count?
What is count? Let me see. Well, count is supposed to be our dictionary. Oh, it prints the whole dictionary?
Yep. So if you see here, count is pointing to this whole guy right here that's slowly building on us. So if we go all the way to the end and look at this, that's what it printed. Was everything in the dictionary. So it counted how many times I happened, how many times T, the empty string, so on and so forth, all the way through.
Yeah. Now I get the pretty print, the PP print, but I did not get the PP print .p format.
Me neither. So glad that we're in Glut company. Okay, so in case you're not sure what we're talking about. So we printed all of this, and it prints like this, basically just one long line of characters. But P printing, he introduced us to the P print module. And then instead of doing a normal print, we did a P print dot P print, and it organized it so that it was a lot easier to see. So if we just change that last line here, oops.
Do you have to import it first?
Say again?
Do you have to import the module?
Good call. Details, schmeetails. Okay. I hope I did that right. Okay,
Yep.
so now it looks like that. So it's not
Beautiful.
off in the weeds. You can sort of see it.
But what was the other one you said you didn't understand?
So he says there's this thing. If you don't want to do pprint, you can do this print pprint.p format. But I'm not sure why.
I think it's just the syntactical sugar.
I'm not sure what that means.
Yeah. So in other
Oh.
words, if you want a string, yeah.
So basically what it is that, the first portion, you're calling a class and then the same method that's also called pprint to do that. It's the second line where it says print, pprint, .p format, it's somewhat more readable. If somebody is not familiar, let's say, with the pprint module, like me, I'm not familiar with it. It tells me, I know what print does. Okay, it's trying to print this one thing, and it's trying to format something. So in my head, for somebody who's not used to using the pprint module, it's more readable for me. So I guess it's an option. Sometimes when we code something, it's not just because we do it for the functionality, but we also do it sometimes just because we want other people to be able to read what we're doing. So in a way, syntactical sugar for me means it's easy on the eyes and it's easy for me to understand.
Which I think that is an excellent thing. The other thing is that if you did not want to print that right away or rely on pprint to insert the return characters in it, say you were kind of, I don't know, compiling a report, we'll make up some silly excuse, you could assign pprint.p format to a variable, and that variable could hold that string for you until you wanted to print it later. So that may be another reason why you do that.
That's a good point. That's a very good point.
Because it'll hand you back a string rather than doing terminal output. But I like your reason as well, because the readability, even though there's more dots in there, the readability is greatly increased for me if I see print. pprint doesn't scan for me. Print definitely does. You want to take print out of, you assign test to the print function. Take the print function off on line 10.
But is that not what you were just saying, that it assigns it to
right, but you don't want to call the print function. You want to call pprint p format and assign that to test. Right? So take the print, yeah. Now assign test to that. You need to take the yeah. Yeah. Right. So you get the same result, but say what you wanted to do was you wanted to say, print the string, and here is my dictionary, colon, and then the dictionary. You could say, here is my dictionary plus test, and then print the whole thing. Because test is actually, right, p format is returning you a string. So you can actually add more things to it. So I think that's what they're talking about with the difference between p format and pprint. So if we went back and edited the code one more time, in front of test inside of the print function on line 11, either in front of it or in back of it, yeah, you just type a string, like just say, our result is colon. Yeah. Now that should print out together. See? So that may be why you'd want to call the pretty print function p format as opposed to pprint, because it's assembling a string for you. So like for a report or something like that, then you can manipulate it further.
Okay, I will accept it.
It is acceptable.
I'm gonna sit here and just keep thinking about it, and I will accept what you say.
Yes. Still dubious, but acceptable.
Right. Okay, so that actually wraps up all of the new stuff that we are going to learn this week. Next week, we are going to start back in here. Wait, hold on. Before we wrap up and I say what we're doing next week, does anyone have any last minute questions about what we went over today or anything we want to talk about?
So we'll go over all the questions next week.
Yes.
Okay.
I have one thing to add, but we don't have to. There is a cool Python shortcut for that counter function that we went over. But I can also paste it in the Slack channel later if we want to just answer questions and sign off. As you know me, I'm known for making these longer than they need to be, so.
Yeah, let's hold, well, okay, let's wrap up, and if anyone needs to go ahead and get them to go, and then we can talk about it in just a sec. Okay, so to wrap, any other questions before I wrap up this lesson?
I just want to say, I think it's great that we're taking 2 weeks per chapter because I can spend more time studying the material.
Same here. I agree with you. And also it's helpful, like whenever you do see that extra stuff where you can come up with some extra questions, then we can spend more time asking them and not feel rushed. So that's awesome. Okay. Any other commentary? This is chapter 5. We're going to pick up back here with using data structures to model real-world things. Essentially, we're going to be making a tic-tac-toe board. So that's going to be fun. So just in case, it looks like we're also going to hit on some nested dictionaries and lists. And then we're going to review all these fun practice questions, holding those to make sure that your mind is nice and fresh and can come back and remember all of these for next week. And we even have a fun little practice project down here at the bottom, 2 of them. So if you want to actually get in a little bit of practice, feel free to jump into one of those. And we will review anybody's code. If you want to go ahead and try to code these and you have problems with it, we can look at your code tomorrow. Like, we'll share your screen and we'll work through it next week. So please feel free to come back same time next week on Thursday. If you don't have any other questions, or if you do have any other questions, please stay on the line. Otherwise, you are free to move about the cabin, go about whatever you need to do, or just go to sleep, which is probably a great idea at this point. Let this all ruminate in your head. But thank you guys so much for coming. Really do appreciate it. But you are welcome to stay on the line if you want to hear some cool, juicy stuff that Bethany wants to talk about. Other than that, have a great evening.
Bye. Thank you for coming.
Okay, Bethany, tell us.
All right. So if you go back to the code example that Lisa so wonderfully walked us through, where we were counting items in the string.
Got it.
I don't know if you have Python.
You want to do the visualize over here?
Yeah.
Okay.
So if you go up under import preprint, if you also import, actually do one line down, do from, not import from, just from. You want to from collections.
Oh.
Import counter, but that's with a capital C. So counter is magical. It is one of my favorite things. Collections is a module that has special types of dictionaries and some other goodies in there. So instead of on line 5 count equals empty dictionary and doing this whole loop, what you can do is comment out all of that code from line 5 through line 10.
So I've only learned this. Is there a block version of this?
There is. It's a triple quote. And so you do triple quotes on the line above and then triple quotes on the line below that you want to comment out. And you can either use single quotes or double quotes. Yep.
Like that?
There, and then all the way down to there, and then another one. And that comments out the block. That's a block comment.
Okay.
Yeah. All right. So you can say count, so call it count equals, and then counter with the capital C with an open and close parentheses. And then you can actually, what you can do is put message inside of counter, inside of the parentheses. Okay. And now run it.
What?
That's all you need. Yeah, just run it.
No.
Oh, I think she
I
needs
don't
to
believe
change
you.
test into count.
What?
Oh wait, does she need to change test into count, or she just needs?
Oh yeah, she no, she doesn't. She doesn't, because we've named the dictionary count. So yeah, I think if you do visualize execution, I think that.
Oh, because she commented out the count dictionary actually.
No, we renamed it on line 5. Count equals counter message. Yeah, yeah.
Oh yeah. Got it.
Okay.
I want to see what you're doing here.
One step is what I'm doing here because I'm lazy as all F. And that's what counter lets you do. One and done.
Oh.
Oh, wow. I didn't know you were that lazy, Bethany.
Oh yeah, I am extremely lazy, and Python lets me get away with it. So counter is a special type of dictionary that takes anything that is iterable, iterates through it and counts it up, and returns you a dictionary.
Anyone see anything interesting about this dictionary?
It doesn't use the curly brackets.
Oh, it does. There's curly
in your
brackets right there.
in your code. I don't see the curly brackets in your code.
Oh, well, we didn't define it. It looks like the counter defined it.
Yeah, the counter, that counter is a class, but counter is also the constructor. So basically what we're doing is we're telling the counter, hey, our iterable is message, make us a dictionary. And the counter code counts up the things in the iterable, in this case the string, and hands us back the dictionary.
Yes, that's what I was looking for. The order is different.
Nice.
It's sorted, ascending order, I mean descending order.
Oh, by count.
Yeah.
Oh, nice.
Look at that, yeah.
Lovely. This also comes with extra methods. So you can ask this counter object what the most common is and what the least common is. So there's some handy things. That is awesome. Yeah. So the order is not in the order that it was fed in, which may or may not matter to you.
Well, that is so cool.
Yeah, I kind of sort of like it a lot.
I can see how now.
But it is also, as was pointed out, right, if you need these things in the order they went in, it might be better for you to do it manually. And it's no faster, right? Because underneath they're both dictionaries, so it's doing the same thing. It's just this is a shortcut that kind of does it for you, whereas doing it longhand. But if you needed, if you needed special processing in between, you would want to do it longhand.
Wow, look at how small and beautiful that is. Okay, sorry, I needed to see it without the comment. Huh. Okay, any other magic you'd like to show us?
I think I'm all out of unicorn farts today.
Okay, awesome. So what we're going to do is we're going to add all the code that we went over here today to our GitHub account so that everyone has access to it. And we'll post it in Slack so that you can see it, play around with it, do whatever you need to do. Any other comments or questions people like to share before we sign off?
Good job.
Yeah, excellent job. Thank you so much for facilitating.
Yep, no worries. Thank you guys so much for participating, especially you, Bethany, always there to save our lives. Kevin, thanks for chiming in. Lisa and Liliana and everybody else on chat. Minakasha, Danielle, sorry if I pronounced your name wrong. Thank you guys so much for participating. Definitely appreciate it and hope to see everyone back here about this time next week, okay?
Hey,
Cool. Bye.
bye.
See you guys. Good night.
Good
Good
night.
night.